This video is going to show you how to upload the firmware to the Arduino of your Hyperspectral imaging system. Okay, so first you need to open Arduino IDE, which you can get for your operating system. Make sure you have this Accel stepper library installed, so find out how to do that. Otherwise it just uses standard libraries. Next, you need to make sure the board is attached. So here I have plugged in the USB cable to my Arduino and plugged it into the computer. And then you need to select your board. So this is an Arduino Nano. And select the port. So on my computer it's reading it at this port. And you can just check that there's a board attached there. It tells you the ID of the board and so on. Check it's communicating with your system correctly. So in Arduino, upload the code. So this is the code available on GitHub. There's not really anything you need to change here yourself, except perhaps this one line. So this is a unit number. If you have multiple units that you're intending to make, you need to know which unit is which, so that each unit has its own calibration data, and so with each measurement that's recorded, it looks up the unit number and the calibration data relevant to this. So when coming to calibration, consider changing the unit number if necessary. So this code is just doing a bunch of stuff to read the spectrometer. It's sort of heavily based on the OSPRAD code. And you can actually interact with it in certain different ways. But first, let's load this to the board. So first you need to go verify, and it will compile the sketch. So done compiling, it's all happy with that. That means all the libraries and so on are there. And then you just need to press upload. It will recompile it and now upload it to the board. Done uploading. So now we can turn on the serial monitor. So tools, serial monitor here. If you look in the code, we are using a serial port with this baud rate. So what you need to do is make sure your serial monitor also is using this baud rate. And now there are a few functions we can use just to test the spectrometer, the hyperspectral camera, and see if it's working. So here, for example, if we go down to the bottom of the code, there are the functions to do different things that we can specify just with the serial commands. So if it detects something in the serial port beginning with a T, it thinks that this is setting the integration time manually. We can start it with a P, and that means manual panning. So let's do this. So if I go P100, the unit, you see, it's just moved to a new position. And if I tell it to go back, P0, it will go back to where it was. There's also this tilting thing, so we can have the tilt axis run on its own. So something starting with L and then a number is for tilting. So let's make it tilt at 90 degrees. So L512. This should look at 90 degrees. Perfect. And L0 to send it back to where it was. Whenever you plug in the HOSI system, make sure it's in this starting position with it looking forwards and down. Now we can also actually make it take a hyperspectral image using code here. So if it detects a line in the serial command beginning with an H, it's looking for these commands. So if I type in here H, the first numbers are shown here. So that's pan left and pan right, the coordinates of that panning. So here minus 200 to plus 200. And then the pan resolution. And these are all in stepper motor steps. The stepper motor has 2048 steps. It can vary, but that's the standard for this stepper motor. The one I've tested it. They can be very slightly different to that, but that's broadly what you're working with. So here I've got a pan resolution of 10. That will actually take quite a lot. So let's just put that to 100 so it doesn't take too many. And then here we have the tilt bottom and top, and again the resolution, so tilting from 400 to 600, and I'll set it at a resolution of 100. Then the max integration time in microseconds, here it's set to 2 seconds. The boxcar, so that's the spectral compression number, which is 2 in this case. So it combines, it takes the average of 2 recordings from each position. And then we've got the how often it should repeat the dark measurement in milliseconds. So here we've got 120,000, so that is 120 seconds or 2 minutes. So every 2 minutes is going to take a new dark measurement. And just, you don't need to worry about these, defaults are fine. Now if I press enter, it should come to life and take a scan. First it just initializes this, the spectrometer and takes a dummy reading to sort of clear out the sensor. Now it's taking dark measurements at different integration times. Now it's actually scanning. See, it's moving around. And there we have it, done. So it's given a little X at the end to show that it's finished. And here's the output. You can see it, obviously it produces a lot of output. For every pixel, it's giving you the location in pan and tilt dimensions in steps. Then the 1 and the 0 here, the next one, are telling you what type of measurement it was taking. And the integration time, so whether it's a dark measurement or a light measurement, and so on. Anyway, these are the data that are output, and the graphical user interface will make sense of all that for you. Okay, so there we have a working system.